Hello, class. This is a lecture on SQL 8. We're going to be talking about group by and having. At first, you may not see the utility here, but trust me when I tell you this is a very, very important lesson. Not only for the exam purposes or for the class purposes, this is very useful. You will find this very, very useful in your professional life as well. So, all right, to start out, what I'd like to do is go ahead and create a table. I believe I already have a table named students here. Yeah, I do. Okay, so what I'd like to do is start out by, I'll build a small table and we'll do some examples here together and we'll show kind of what grouping does, the utility here. So I'll start by creating a table, and I'll call it students, right? I'll give a first name, last name, and maybe a student ID. We'll make it an integer. And I'll go ahead and insert some records. Bob, I don't know, it's a generic name, Bob Smith. And I'll give him a student ID of 1, so we're starting at 1. New record, John. John Q. Public. Couple more. And you know, since we're testing grouping here, I'll do a small, this is going to be a small table here, but I want to have at least one entry with more than one row for the purpose of this lecture. So, gosh, I'll create another Bob entry, and this guy we'll call Bob Brown or something generic like that. And one more, let's see. We'll not be sexist, we'll go with Jill. Jill Jones. All right. So let's say we have a requirement to view, or we just want to tally up how many students have each first name. So we could, let's check out this table first. Select all from here. We'll be nice and, there we go, do it nicely formatted. Okay, Bob, John, Bob, Jill. All right, so I can see that I have 2 Bobs there, but what if I had a really, really long list? I could do something like this. Might make it a little easier on me. There, now it's a little easier to see that I have 2 Bobs. You know, if I had a table with 10,000 values, it might be a little easier if they were kind of contiguous there. So I can tally them up that way manually, but that's still not right. So let's see. So I want to count. So maybe I should use the count function, right? Because I kind of want to count the number of entries here. So what does that mean? Should I do something like this? You know what? We're counting first names, right? See, that gives us the whole table. Ooh, I know. Order by first name, right? Right, that'll give us a count by first name, won't it? No. Okay, so what we're doing here is messing with an aggregate function. So count is an aggregate function. You know, it aggregates data, kind of groups data together. So when I'm doing this, it's just saying, okay, you want to count the number of first names, the number of non-null first name. Actually, excuse me, this is a count function. That doesn't even apply. So let's just say what I'm telling it is, here, I want you to give me the number of first name entries in students. This here is kind of regardless. We're not ordering by anything because look, select count first from students gives me 1 row. So here, I don't even have first there. I don't have my first in my results set. It doesn't matter. Order by first didn't do anything there, and that's why. So what I want to look at is using an aggregate function in the correct manner, or in the manner corresponding to the output that I want. So count is an aggregate function. And I think we've already looked at these in some contexts. Aggregate functions include average. We have count. What else we have? Max and min. We have a couple of mathematical ones. There's standard deviation and there's what variance. There's some. And there are a few more. There are some that are subsets of these, particularly variance, standard deviation, but they're not really distinct enough to talk about those. But anyway, these are kind of the major categories of aggregate functions that you'll see and that you'll use. All right. Now, aggregate functions, with this exception here, with this count exception, aggregate functions ignore null values. Now, count will count null values. If you tell it count first, let's say I'll go ahead and insert a new row in here. Insert into students values null. What did I leave off at? I don't know, so I'll just say 9. I know I haven't put 9 values into that table. Now select count. Oh, you know what? Excuse me. Sorry, I'm 100% off here. Okay. Count will also count nulls. So let's do something like this. Select count asterisk. Select count of everything, right? From students. Now we should get, there's 5. So this will ignore nulls. That's why I get 4 there. Now, if I select everything, it's going to recognize a new row. So it will return 5 instead of 4. So sorry about that. I'll go ahead and delete that bogus row there. Delete from students. Hey, what would happen if I forgot to put my where clause in there? I'd wipe my table, right? So always be careful when performing delete statements. Always, always, always be careful. Do a select first. Make sure it gets the results that you want to delete, and then change it into a delete. Yep, there we go. All right, and gosh, what was I even talking about here? So, count asterisk will include null values. Count of any specific columns will not. So, when we group, we'll kind of funnel this down from aggregate functions in general to just grouping. We'll talk about count anyways. So when we group, that will allow us to divide this input. Like, for example, let's see. You know what? We'll get into examples in a minute. So what group by does, it kind of divides the whole table into sets, okay, based on the values that you group by. So let's jump right in here. We'll go ahead and start. Let's say, let's do this. Let's look at this. This will show us what's going on here. Okay. Right? Notice that I have my count kind of partitions the table, if you will. When I group by, the group by kind of partitions the table. So what it will do is get a count for each unique first name in the table. And it will tally those up by that first name. So I have 2 Bobs, right? Let me make sure here. Select all from students. Yeah, so I got 2 Bobs, I got 1 John and 1 Jill. So this is Bob, and then this is going to be John, and this is going to be Jill. Okay. Now, I'm not happy with just a count. I got a count here, that's fine, but how do I know this is Bob? There we go, look at that. Okay, so now what I've told it is get me the count of first names as well as the first name from students. There we go. So now I have Bob, Jill, and John. Now, let me think about this. What else could we want to do here? I know. Let's look at it this way. Now let's run this group by again. Okay, so notice now, what if I want to get the maximum? What if I want to get the most common first name in this table? Well, okay, I've got them partitioned by, or grouped by first name, but, Jill appears here. So what if we have 10,000 unique names? We'll have 10,000 different rows. It'll be too hard to find which one is the max. So maybe this will help us. Let's throw an order by in there, maybe. Let's see here. Count. All right, let's see what this does. All right, so I have a order by count in descending order. So maybe this will order my output. There we go. Look at that. So now I've got my number 1 row on top. Still, it's probably not good enough. What if programmatically? What if inside some kind of app, I just wanted to return, instead of having a whole result set come back to the application, the application shouldn't have to sort through that. Let's say we just want to get the most common name in this table. Let's see. Ooh, I know. One of the aggregate functions we talked about was the max, right? So let's maybe something like this. All right, so I'm going to get the highest number of counts from students. And yeah, of course, I'm ordering, I'm kind of partitioning or grouping it by first name. That looks to be right to me. Let's see here. Yeah, hey. All right, I came back with 3, and that's what I would expect. How do I know this is Jill, though? Let's go in here, and we'll change. Okay, select max count first from students grouped by first. That should do it, right? That's going to get her done, as Larry the Cable Guy would say, because, let's see, max count first. Yeah, absolutely. It should. I mean, looking at this, it should give me the first name corresponding to the highest count there, right? No, no, no. And in fact, this is referenced in the book here. This is an aggregate of an aggregate, and it has to do with the way, the order in which the operations are performed in the DBMS. So just know that you can't do this way. Sorry, you can't shortcut. Let me think about this. Okay, I see an easy way of doing this. If I want to be lazy, yeah. All right, so let's go back up here. You see what I did here? Actually, even further up. Look at this. This ordered my output in the way that made it easy for me to pick off this top row, kind of visually. So what if we picked off the top row via SQL? Let me look here. Yeah. You know what? Here, forget it. We'll just go for the gold. Where was I? Okay. I will use this as a subquery. Actually, you know what? Let's try this first. Select count first from students where, look at this. This, I see I'm going to have to change this, but anyways, where row num equals 1. That should give me my first row here, right? So select count first from students where row num equals 1. Group by first. Order. We ordered by our count descending, right? Count des. Okay. So I have the same thing that I have up here, only I specified row num equals 1. I'm trying to pick this top row off. So let me fix my little mistake here. What was it? Students. It should be students. 3. I'll change. That looks right. Uh-oh. Oh, man, what happened? Well, let's go back up here. See, I would have expected Jill. Instead, I got Bob. What the heck happened here? Well, okay. Where row num equals 1, then I grouped. Okay, that's what happened. I had not yet grouped when I told it where row num equals 1. So, here, I'll show you visually. Select all from students. Yeah, Bob comes first. Therefore, it picked Bob off the top row. See what happened there? It just picked Bob off, and that's why I have 1 in the count as well, because all it did is pick that top row off. All right. So that tells me we're going to have to change this order of operations somehow. We'll have to grab all this stuff minus the row num. So we'll have to grab, gosh, where was I? Bob, where are you? Yeah, so we'll have to grab this and then apply row num equals 1 on it somehow. Okay, here's an idea. Let's select everything in here where row num equals 1 using this as a subquery. So select all this junk where row num equals 1, right? Because I'm doing my sorting here, and if I had this as a subquery, if I pick the first row off of this in my output, then that should be my answer. So let's try this again. Oh gosh, I hope I don't get lost in all that, in all this here. Let's see, select count first No. See, I did get lost. Okay, so select all from, then my subquery. Oh gosh, what was it? Select count first from students where row num equals 1 group by first order by count. Let's see, is this correct? Should be, yeah. All right, so I kind of like to look at everything here before I execute it. Select everything from count first. Oh, you know what? My inner query, I don't need that where row num equals 1. That's on the outside. I was thinking about what I did earlier. So I'll change where row num equals 1 to nothing. So let me look at this again. Select all from, select count and first from students. Group by first. Okay, so I'm grouping by first. I'm partitioning by first. Order by count descending. So that will leave gosh, what was it, Jill with a count of 3 on top. So I'm selecting that first row, which should be Jill 3. Let's see. Hey, all right. So it was kind of I shouldn't feel too proud of myself. That was kind of a lazy cheater's way. There's a better way to do this. Let us try, let me look at my stuff again here. You know what, here, even better. I don't know about you guys, but I get lost in this stuff easily. Easily. There we go. So we have Bob, John, Bob, Jill. All right, so I want to find this most common name. I don't want to do it kind of the cheater's way by ordering and then picking the top row off. That max count seemed to work fairly well for us. Let's see here. What was it? Select max count from students group by first. Oh. Oops. Linux had it. Select max count. Aha. Yeah, that looks right. Yeah. So there's number 3. Let me think. Something else I could do then. Yeah. I could use this as a subquery, right? So I could pick everything from the students table where the count equals 3, where the count equals, my subquery will produce the maximum result. So what I can do then is something like, heck, here, I'll just, I don't even want to select everything. That was students. Aha, here we go. Now having count equal to, and how do I get 3 out of here programmatically? Oh gosh, let me look at this and make sure this seems right. So I got select, okay. Select count and first, and I'm, okay, let me try this one more time. So I got select count and first, and I'm grouping by first, so I have to include first, right? You have to group by everything that's not the aggregate function from students. So having count, where that count is equal to the max count. Voila. There it is. All right, so that's kind of another way of finding the max, per grouping set or partition set, however you want to look at it in a table. Here, let's look at this. Okay, see how I just mentioned everything not in the aggregate you have to group by. Well, let's look at this. I know. Let's introduce yet another Bob. Okay, let's look at our table. So we got Bob Smith, Bob Brown, John Public, Jill. Okay, I'm going to duplicate this guy since he was the first one. I'm going to create another Bob Smith. So okay, so now I have now I have 3 Bobs, 2 with the same last name of Smith, 1 John and 3 Jills with different last names. So let's look at this. Let's say, okay, so I still want to get, let's say I want to find the number of people who have each first name. So that's going to be a job for the count, and I'm partitioning by first name, right? I'm grouping by first name from students. Yeah, we got 3 Bobs, 3 Jills, and 1 John. Now, let's say I want to find unique names in this table, or how many people share, just forget I said the word unique. How many people share the same first and last name for each first and last name combination? So I would expand this. Let's see here. I want a count of first and last name combos, right? And, whoops, not a group by expression. Well, you see why. I don't have last here in my grouping clause. So I can change this, and, all right, so let's see. I got a count of first and last names partitioned by or grouped by first and last name from students. All right, so I got 1 Jill Smith, 1 John Public, 1 Bob Brown. Hey, Bobby Brown, wasn't it an R&B guy back in the day? I got 1 Jill Johnson. There we go. 2 Bob Smiths. That's what I was looking for, just to verify this. All right, and 1 Jill Jones. So you see that group by partitions or groups our data into kind of subsets, if you will, on which the aggregate function is performed. So that's why when I do, up here, if I just group by first, all it's doing is partitioning this this table into first name groups. I really shouldn't say partition. There's actually another function called partition. I'll just say it kind of groups. It breaks this table up into subsets grouped by first name. Or down here, first and last name. Okay, so these operations are performed on those subsets on which the table is broken up into. Let me think. There's also, I want to kind of expand this, and I don't really want to just look at count. We talked about the aggregate functions, count, count, max, min, sum. What else? Standard deviation, variance. Let's use average. Average. Yeah. We'll talk about average here. So, okay. Average is pretty good on, say, numbers, numbers of things, or maybe money. So with that in mind, let's do another table. Create table. Sales. That's a good example. It's kind of a classic example. So we'll say we have like a salesperson ID. We won't use long names. A sales region. Yeah, that's going to be a good example for grouping by. And then of course we'll have kind of the monetary amount that they sold. We'll say like sales amount. We'll represent that here in monetary format. So, hey, I already have a table called sales in here somewhere, so pretty sure I'm not using that for anything. So, salesperson ID, and I'm kind of copying from above here as I eye it. Region. All right, good. We'll insert some values in here. I'll just insert some different values. We'll start with salesperson ID number 1. Let's do global regions. We'll say like North America here. So we sold about 100,000 last year. We'll insert more rows. Europe, Middle East, Africa, like 50,000. North America again, we'll say, 80,000 or something. We'll duplicate our EMEA sales. Million went up. And we'll create a new one, Latin America. That sounds good. Okay. What did I call this thing? Sales? Yeah. There we go. So salesperson ID. Let's drop. We're not even using this for anything. I'll drop that from the column selected region, sales amount. Maybe we'll be able to. Maybe it won't wrap this way, and we'll be able to see it more cleanly. Yeah, that is better. So I see I've got two Latin American. Two North America entries. I've got one Latin America and two Europe, Middle East, Asia entries. So let me think. Okay. So we wanted to play with average. So actually, here, remember, we can do this with count. We can count everything. Basically, we count all attributes across a row. Basically, this means we count a row. Okay. Now, we can't do the same. Let me see here. Average. Yeah, see, not okay. We can't average everything. Oops. So go back to look at my table again. All right. So what I want to do is let's get an average sales amount. That seems like a reasonable request that a manager might want. How much has the average sales rep sold? Looks like 258,000, give or take here. Now, let's say we have a requirement for getting the average sales amount by region. How do we do that? Okay, we'll kind of break this table up into regions with a group by expression, right? That's what this does. This breaks the table up kind of into smaller tables, and then we can perform our aggregate function on those kind of smaller broken up pieces of the table. So that means okay, I also want the region name, right? Or else the report is kind of useless. And we'll have to group by everything that we want to average. And really, I'm only grouping across region. This way, I get an average sales amount by region. And we know that because I'm breaking this table up by region. So, hey, there we go. Look at that. Latin America, yeah, we had the one entry for 59,000, I think. EMEA, here, let's go back to our table. Select region, sales amount from sales. So yeah, Latin America had the one entry. Europe, Middle East, Asia, that looks about right. Because we have 1,050,000. Yeah, that's correct. North America, let's see, we have about 90,000. Oh yeah, yeah, that's dead on. How about this? Okay. Remember earlier I said count will also count nulls. Count across any particular field will not. Now, nulls are kind of special with aggregate functions. Only count asterisk will include null values. The rest of the aggregate functions really won't. And here I'll show you what I'm talking about real quick. We'll insert a null entry. Let's say, since I'm doing all of this, let me think about this. Yeah, since I'm doing all this on sales amount, let's insert a null sales amount. Insert into sales values, I don't know, North America, whatever. And we'll say null. Let's say for some reason, okay, so let's say for some reason this salesperson, let's say he was out the whole year, or let's say he was added to the database. This is for a certain year. He's added to the database, but he didn't work here in that year, something like that. So we have a null entry in here. So actually, the formatting is a little bit off here. We'll make the columns. We'll choose less columns, I guess I should say, so we can kind of see this more clearly. Just a moment. Okay, sorry about that. I didn't realize that I already had a salesperson with a sales ID of 5 in the database. So I'll go ahead and insert a genuinely null row here. So insert into sales values. What is it? 6 is going to be actually my next unique salesperson ID. So North America, and we'll say, null. He didn't do anything that year. Maybe he wasn't, genuinely with the company, whatever. So select Okay, so here's our whole table. Yeah. So now I've nulled this guy. That was the entry I tried to insert. It was already there. So anyways, now we have a null entry into this table. Let's see how this affects us now. Remember I said aggregates should ignore nulls. Amount from sales. So with that, I would expect this result to be the same as before. Yes. Remember we had about 257,800. Sorry, I kind of cleared my screen here. You can go back in the video if you don't believe me and verify. Select. Okay, so let's take a step further. We see that this didn't affect us. Let's go ahead and group by region. Since this is North American, will this affect the North America stats? This shouldn't, right? Remember our North America was what? $89,999.5. So if what I'm saying is true, we should have that output when we group by region. So select average sales amount from sales, and we're grouping by region. Hey, all right. Sure enough. We have our 89,999.5. I didn't include any other columns. I probably should have so that we could see the region name. But anyways, no value does not affect any aggregate functions, except for count asterisk. You know what? Actually, we can override this. Let's say here, this is interesting. What NVL, the null value function, does is if a value is null, it will assign it a value of your choosing for computation. So let's take another look at this. Select average. Sales amount. Here, let me give you some background. What our manager tells us is, hey, I don't care if the guy wasn't working here. I don't care if he wasn't in the database. He needs to be counted as 0 in this report if he exists in this table. So let's say select all from sales. Okay, so this guy number 6, he has a null value there. However, our manager says it doesn't matter. You have to count him as 0. Okay, if he appears in there, he's a null value. It doesn't matter. I don't care. I want him at 0 in this report, right, that I'm running averages on. So I say, okay, we can substitute 0 for null using the NVL expression, null value expression. So we will average on sales amount, and where it is null, we count it as 0. Now instead of 279,000 and change, we've got 214,833 because we're splitting this another fifth of the way. So yes, this did affect our output. Now, I bet if I group by region, North America is not going to be $89,999.50 anymore. So select average null value for sales amount. If they're null, count them as 0 from sales. I missed this. Group by, what am I grouping by? Region. Okay, so let's take a look at this. Okay, select an average of sales amount, and if the sales amount is null, substitute 0 in there for your average computation. From sales, we're breaking the sales table up into regions, so we're performing this per region. So let's see what we got. Oh, yeah, that brought us down considerably, right? We're not anywhere near 89,999.5 anymore. Okay. There's another topic here that we can talk about. There's a discussion on where versus having in the book, and this is important because if you decide to be a DBA, application developer, support, whatever you're going to be, you'll run across situations where you need to optimize queries. So let's take a look at this. Here, think about this. Remember, if you go back to the sorting PowerPoint, efficient sort operations operate on the order of n times log n of the input, where n is the number of elements in the input set. So with that in mind, check this out. What do you think would be more efficient, to sort 100 records or to sort 10,000 records? And you can think about this computationally. You can think about it in real life. It doesn't matter. You've got 10,000 records in front of you. It's going to be hell to sort them, right, compared to 100. So if we think about this computationally, that's even more so because, well, probably even in real life, the increase tends to be nonlinear. Let's check this out. Okay, so let's say we have 100 record input. That means that this will take, 100 times, n log n, right? That means it will have to, on average, actually that's kind of in the best case, perform 664 computational operations in order to sort an input of 100 elements. Now, let's say 10,000. Let's say we've got 10,000 elements. Whoa, that's a lot more. That's over 20 times. That's about 20 times more. Okay. So if we just increase our input by by 100. Notice it's nonlinear. However, we still have a pretty darn big increase there. So we got 132,000 operations that we're going to have to perform on this. Okay, so with that in mind, what this means is when we sort or when we filter, anything like that, we want the smallest input set possible. So we want to filter before we do any sorting, aggregating, anything like that. So if we look, let me see, we had what? Select region. I'll just go back to a couple that we had. Sales amount, right? From sales, where? Here, let's say. Okay, so let's say we want the region along with the average sales amount for the region, because we're grouping by region. We break this table up into regions, and we perform an average of the sales amount on each of those regions. It's an easy way to think about it. And we'll just say this is kind of a nonsensical comparison, but let's say we want, for alphabetical purposes, it may not be that nonsensical in fact. Let's say we want regions that are greater alphanumerically than Latin America. Okay, all right, good. The only one we have is North America. Now, I'm sorry, I right-clicked there. I shouldn't have. Now let's, okay, here. We can do the same thing with having, and in fact, this is what we did before. Select region average sales amount from sales, group by region, having region greater than Latin America. So we're kind of doing the same thing here. Let's look back to here. What we're doing here is we're taking all regions greater than Latin America, and we're averaging those sales on those regions. What we're doing here, this is a little bit different. Look at this. we're selecting all the regions, grouping on all of these regions. Then we're filtering our results after grouping. We're performing some extra work here. Think about this now. Here, I select stuff from sales where, okay, I select stuff from sales, I filter it down, then I group on this stuff and perform the aggregation. So I have a smaller result set. I'm grouping and I'm doing this stuff on a smaller, narrowed down, filtered result set. Here this ain't the case because, let's look at this. This is not the case here because I'm selecting stuff from sales. Hey, whoa, I'm grouping and averaging everything because I haven't yet filtered my region. Now, after all that work, I go ahead and filter. That doesn't make as much sense, right? Maybe you prefer the having keywords. Maybe your app is small enough you don't have to worry about it. But you want to filter on a smaller, you want to do your work on a smaller result set after filtering, if you can, right? So this one here, we should get the same result. Let's verify and make sure I didn't make any mistakes. Yep. So we've got the same result set. Here, I did less work because I filtered before I did my hard work. Sorry, just a moment.